Hello and welcome. Today I'm going to be going through an experimental project I did in which I attempted to install LED backlighting for the liquid crystal display of an inexpensive label maker. I went into this project knowing it might not turn out very well, and indeed it didn't. But technically, I did succeed in my goal of installing functional backlighting. The first step was to disassemble the unit enough to allow me access to enough of it to get the job done. This was the easy part, as it meant doing little more than removing a number of screws from the bottom of the unit and two behind the display, freeing up most parts of the case. Some of these screws were located in the battery compartment, which is a common place for them. This is usually a good thing, as it forces one to remove the batteries to a device before disassembly, which is the best practice for almost any disassembly. The label maker itself was mostly foolproof. Most of its components are well secured, and only the paper cartridge door came loose when I opened the casing. Thankfully, I didn't have to do any disassembly of mechanical components, since the printing mechanism was entirely contained in an area of the label maker that I didn't touch at all, save for later use of some empty space there for installation of the LEDs used to provide light behind a display. Once I got the label maker open, I found that for the most part it was roomy enough to work in, which made it ideal for installation of additional components even though it wasn't originally meant to contain them. In order to complete my installation as planned, I needed room for three things: at least one LED, a power source, and a switch to control power from outside the device. With the unit open and the display exposed, I began to examine what I had to work with. As expected, the LCD had an opaque rear lining. This was no surprise because the display was intended to be used without a backlight and needed to reflect light from the front back out, rather than allow light to pass through the display from behind it in a backlit configuration. Since LCDs are transparent in nature, I knew I could replace the rear lining with my own more transparent lining to provide a solid background on which the LCD's graphics would appear clearly, yet also provide some degree of diffusion to spread light from a finite number of light sources across the entire display. In comparison, this is probably the most time-consuming part of the entire project because of how much time I had to spend cleaning the leftover adhesive from the rear side of the display. Even if I didn't expect amazing results from my end product, I didn't want residue from the adhesive to worsen the appearance of the display. To clean the display, I began by scraping the bulk of the residue off with the sharp edge of a hobby knife. When I started this process, it didn't seem to be going very well, but that was easily remedied with frequent applications of small amounts of rubbing alcohol to the work area. By keeping the surface saturated with alcohol, the residue was kept workable enough to scrape off using a knife. What little was left over, I was able to clean off using cotton swabs and more rubbing alcohol, leaving a smooth surface free of any remaining adhesive residue. It didn't look that great looking at it then, but it looked fine later on when a new backing was applied. With the LCD entirely exposed, I was able to begin experimenting with new backings after briefly verifying that it was still functional. I found an adequate diffusion material in the paper a couple of Apple stickers came on when I purchased a new iPhone a few years ago. This paper, while thick enough to spread light, was thin enough not to block it very much, making it seemingly ideal for the project. With that decision made, it was time to free up some space on that paper for use in the project. On to the parts I used for the modification to the label maker. The first and most important was the LEDs themselves. For this experimental phase of this project, I went with some 3-volt LEDs intended for mounting to circuit boards. With their small size and low power requirement, they were a decent option and available fairly cheaply on eBay from a domestic seller. A functionality test on these is fairly simple. Connect them to any 3-volt DC power supply and you're good to go. Positive is the longer lead, negative the shorter. In the case of this project, I'm powering my LEDs from a 3-volt button cell battery. These are a decent function test power source. Just press the leads to the appropriate size of the battery to power on the LED. I also used a run-of-the-mill button cell battery holder suited for the CR2025 button cell I decided to use. These simply provide connections on the bottom of the holder to both the positive and negative battery terminals. The battery clips in very firmly and stays there until it needs to be replaced. Since I of course didn't want my LEDs to be powered on all the time, I needed to include a switch. Like the LEDs and battery holder, the slide switch I used is intended to be mounted to a printed circuit board. However, I was able to securely attach it to the outer casing of the label maker, and you'll see how I did that toward the end of the video. Using a multimeter, I can demonstrate how these switches work. I'll be using a continuity mode in which the meter will emit a beeping noise whenever there is electrical continuity between its two probes. The particular switches I got are able to switch between two modes in which the middle pin provides an electrical connection to either of the two pins beside it. This can be used as a simple on-off switch by simply ignoring one of the two outer pins. As you can see, whenever the switch is set to connect one of the outer pins to the middle pin, the connection between the middle pin and the opposite outer pin is broken. To begin the installation, I started with installing the switch, as it would be the least fragile component installation of the whole project. I placed the switch approximately where I wanted it and scored the plastic of the label maker's casing with my hobby knife to mark where I would need to make my cuts. Then I used a rotary tool to start cutting and test fitting the switch. After a couple of tries, I had a fit I was happy with, where the switch sat snugly even without being glued in yet. It was then time to start tinning both the wires I planned to use and the leads of the components I mentioned earlier, since it makes things far easier when you go to solder everything together later on. Then I started connecting wires to the LEDs before I started their installation. Since I had basically no way to work with anything directly once it was where I planned on putting these LEDs, I needed the wires connected not only because I wouldn't be able to do it later, but because they would also help me position the LEDs by giving me more to grab onto when handling them for positioning. Installing the LEDs took a lot of trial and error. I had to cut a chunk out of some plastic behind the LCD to accommodate one of them and spend a lot of time with some super glue trying various ways of attaching the LEDs to the drive motor behind the display so that they would be in a decent position to backlight the LCD. This unfortunately is where I ran into the trouble that made this project turn out less than desirably. I just didn't have enough space to move the LEDs far enough back to provide smooth backlighting instead of the stark, rough lighting you'll see at the end of the video. With the LEDs installed, it was time to start completion of the wiring. I connected both negative leads of the LEDs directly to the negative lead of the battery, and both positive leads of the LEDs to one of the outer pins of the switch. Then, using another wire, I connected the middle pin of the switch to the positive battery terminal, making the switch a control point for the positive connection between the LEDs and battery. This wired the LEDs in parallel, resulting in the appropriate 3 volts to both of the 2 LEDs I ended up putting in. Finally, I attached my makeshift diffusion sheet to the back of the LCD as my last step before reassembling the unit. I used some very thin pieces of Scotch tape to accomplish this, though if I really wanted to do it properly, I'd have used Tamiya masking tape or even the type of glue used to attach smartphone digitizers to LCDs or OLED displays. In this particular case, it was unimportant because it was only an inexpensive label maker I plan on getting into again sometime in the future. The only thing to do then was reassemble the unit and try it out. Reassembly was the reverse of disassembly, though I had a couple of screws left over. With a project like this, it's no big deal, though I generally do try to avoid doing that. Regardless, I got the label maker put back together and it feels just like before, except for now, I can turn on the backlight if I want to use it in low light conditions. While it looks atrocious, it does work in the dark well enough to use, however pointless it may be, to be able to print labels in the dark that you won't be able to see without a light source anyway. When I eventually revisit this project, I'll aim at using a better diffusion material that does a better job of spreading light across the width of the LCD, and possibly a different solution for the LEDs themselves as well. I hope you enjoyed this video and got some useful information out of it. The first video to start off my new channel where I plan on doing many more DIY projects, drone customization, and various electronic work. Throw a comment down below if there's something you want to see, and subscribe for more in the future. Thanks for watching.